Good morning. I'd like to start out by thanking the folks at at ASHWA, the organizers of the Open Hardware Summit. Thank you very much for having me here. I feel very humbled to be on this stage with so many other fantastic speakers, so many great messages, so many great thoughts about what the future of open hardware should look like. So my name is Jason Krinder. I'm a co-founder of BeagleBoard.org. How many of you have heard of BeagleBoard? All right, I love it. Thank you, thank you. While I'm being interactive, a couple years ago I gave a presentation on the right message, right, and really talking about we need to be reaching out to people outside of our own friends and family community, and talking about like how do we make open hardware and the value of open hardware kind of understandable by the every person, all right? You know, how do we make it something that everybody understands why they care about us? I think we're really great at serving the needs of other people in our community, and I love to see this community growing, getting stronger all the time. And I love, you know, that we're here in Portland. There's so many fantastic things going on here. I have some family connections here. I love this place, you know, I look forward to us taking, not just growing our community organically, but how do we take it beyond the friends and family? And the question, one of the questions I asked, got quite a bit of response from when I asked this before in Rome a couple years ago, is how many of you believe that the Raspberry Pi is open hardware? When I asked that question in Rome, most of the hands went up. So thank you for building that understanding. It's been a different picture, and it's nice to see that people understand a little bit of what the differences are. And I'm really excited that the folks at ASHWA are starting a certification program, really building awareness of what open hardware is. Yeah, thank you. Thanks to them. And I just wanted to talk about some of the things that I continue to want to see folks in the open hardware community gain some focus on, and I'm hoping that they can learn some lessons from people that have done other collaborative projects and have tried to do some good outreach. So I wanted to talk about Linux and at the Google Summer of Code. So how many of you have heard of Google Summer of Code before? How many of you participated? Okay. So a lot of you have heard of it and not a lot have participated. So it's great that there's that much awareness, but you know, hopefully we can get that participation level a little bit more up. So I think it's important to think about the differences between open and collaborative. And I really appreciate some of the messages we had earlier about, you know, that programming is forgetting. And understanding our own biases. I really appreciated that, and I really think that analogy of that programming is forgetting is so incredibly apt, and it's something that you know, point to, you know, why is Linux and why is collaboration as a model so important, right? And it's because it was exactly because of that, right? The point is to forget, and how do we organize ourselves in a way such that that's a benefit, and how do we work on actually preserving knowledge through machines, so that these things can actually move forward. And I also appreciated some of the lessons learned coming out of you know, failed Kickstarters that turned into success, and just the message there that you know, we need to reach out and work with our community as we're moving forward, right? That's something that that we often lose. So just staying in touch and staying interactive throughout the whole process, and I think we can learn some lessons from these projects to move forward. I'll start off with my conclusion. It's not a really complicated message that I have for you today, but you know, we're really great in the open hardware movement at producing examples for people, and that's what I'll call open. Right? Somebody can go and grab that widget of XYZ to solve a problem. They're going to go take that and they're going to go and solve their next problem with it. And there is some positive flow that comes from people having a solution, modifying it, then people kind of else picking it up and running with it. But it's different than a more of a collaborative model, right? So who's doing the best at something, and how can I just work with them to make that something better? And that's the thing that Linux does really fantastically. Whether or not you love Linux itself, right? It's very collaborative, and it's kind of a one place where I can go and improve code. So I'm hoping to see the end of things like, have you heard of MRAA? It's crazy. Nobody's heard of it. But people try to solve problems in different ways when there's already a way to go out there and solve these problems. And what I want to try and encourage people is to go and find those existing ways and to go and collaborate around projects like Linux to provide the common solutions to things, right? I mean, I think it's wonderful people make all these different solutions, but I think it can be better if we work together. And bring people into the fold of programs like a Google Summer of Code, right? So glad a lot of you have heard of it. We need you out there mentoring. We need you encouraging students to participate. I'm sure there are some other great programs, and I'm throwing this out there as maybe other people can provide me feedback of other ways that we can help mentor and work with students moving forward. And a lot of this is also about tools. For really the tools that we work with for building hardware today are very different than the tools that we work for building software today, and a lot of them actually get in the way of collaboration. I know that there are some efforts out there to build textual-based hardware design tools, like what we have at the chip level, but we really don't have much at the board level. And I think there's some efforts to get behind that, and I'd like to see some of that stuff moved forward. And of course, always putting in plug for BeagleBoard. We're here and are ready to collaborate with you. All right, so why is this Linux thing so freaking amazing? Because it really, really is. So I think that there's something like, I think the current count is something like 7,000 lines of code added a day, something crazy like that. So maybe some other people can correct my numbers here, but that just couldn't be done in other organizations, right? I mean, it's the fastest moving software project on earth, right? And it's completely open source. It's used to run everything from our trading systems on Wall Street to our web servers at Amazon and Google, pretty much everything that we're working with today on the internet, to our mobile phones with Android. It really is something that's everywhere, but yet a lot of the stuff that we're doing to talk to the physical world, the sensors, the electronics stuff, is still moving relatively slowly. A lot of people just, it's a little bit intimidating to them, so they go and create these solutions like MRAA that run everything in user space. Just give me the access to that peripheral, I hack it myself. And there's really missing this opportunity to share in all the advances that are coming from all these other people and companies that are contributing to this common software base. And I think that BeagleBoard is certainly here to help if you're trying to get started with that. But there's so many other possible resources that you can go to, and you just really don't feel like you have to do this on your own. There's this I/O system called IIO. It's very generic. It's the way you talk to sensors in Linux. And we'll all get a lot further if we go into the one place. One of the nice things about Linux as well is that it's architecture agnostic, right? So today the hot thing is ARM, and tomorrow it could still be ARM. It could be low risk. It could be RISC-V. It could be some other new platform that people come up with. But the fact is that Linux runs on all of them, right? You could even run Linux in a web browser. People have actually made simulators in JavaScript that you can boot Linux inside of your web browser, right? It literally runs everywhere, right? It's definitely something to check out. The process for getting engaged is actually pretty straightforward. You create a patch using a tool called Git. Linus went on a wild coding spree when he got frustrated with other code management tools that are out there, and he went and created this tool called Git. That just organizes everything in patches. And this comes back to that point about, programming is forgetting. It's actually pretty difficult to Linux can be very intimidating, right? There's millions of lines of code. Why do I want to put that in my project? It's so complicated. I want to just be able to understand everything. But there's actually a very straightforward process of understanding what's going on in Linux, because it's written in terms of history, right? Every time there's a change, that patch, what lines of code were added, what lines of code were removed, what kind of lines were changed, is recorded in history, in a mailing list, and discussion. Before any patch is accepted, you post it to the mailing list. People provide you feedback on the code. They tell you their concerns, their thoughts, and all that history is recorded in the open for all of us to go from, right? So. If it's about forgetting, this is the way you can take forgetting and then go back and understand what the assumptions were, right? What were the biases that we had when we created this piece of code, and then you can go and make the arguments why those biases are wrong and you need to change them, right? Because it's all there and recorded. And if you understand something, how it works or why it was built in a certain way, you simply look at the history, right? It's all searchable. You could dig through it, you know who this is coming from and why they wanted to go and create things. And there's a fantastic tool now. How many of you use GitHub? And probably you all use other Git tools as well, Gitorious, or what's the new name, GitLabs, right? So there's all these great tools. So it's great to hear that you're already doing that today. It's really from making quality software, understanding version control tools, and being able to track all that history is incredibly important. And it's a huge part of what makes Linux so successful. All right, try to figure out the things I do need to make sure I get plugged in here. Okay, I hope I've covered a little bit of why Linux is so amazing and why you should contribute to it. Other lessons to learn here from Google Summer of Code. So Google has been running this program now for about 11 years with 500 plus organizations. People doing open hardware is something new. So in the past, it's been exclusively focused on software, and as BeagleBoard, we focused on software projects. Not really doing open hardware itself. But then, of course, all the tools that you're working with, things like KiCad or GNU Capture or these other things, there's opportunities for those to become focal points for your projects. There's, I think over 100 different organizations that were mentoring the last Google Summer of Code. We've had some really great success stories come out of our community. We had a student in Spain take an autopilot that was previously for an Arduino, port it to Linux. He then started up his own drone company, got funded in Spain, has a building out there, lots of number of employees, very successful business. It started as just an intern as Google Summer of Code. And now the Linux Foundation has actually taken on the project of maintaining autopilots and Linux called a drone code. Right, and then we've had people just take our boards and turn them into logic analyzers and build things out of that. But just a huge number of success stories. Don't think I want to go on there too much. Oh, this has got animation. Let's skip that. No, let's skip all the animation stuff. But I do want to talk a little bit about how BeagleBoard's doing more to try to be more participatory. Part of that is we were previously using OrCAD for our schematics and layout. which is a fantastic tool and really the right tool for the job for a lot of things, but we've been working on simplifying our board designs so that you can work in a tool like Eagle, and moving forward, I mean, tools like KiCad. So we've taken the most complex stuff off of our boards, 145 components, and put it all into one system and package. So one of my mentors at TI was the inventor of the Speak and Spell. He went off his new company was to go and create this packaging company. He came to me and said, "Hey, what do you think we should go and make?" I said, "The first thing we should go and make is a Beagle on a chip." And that's making it a whole lot easier for people to make derivatives of Beagle, right? So it's in Eagle now, and a much simpler design. I won't go over all the components and the junk inside of it, but just makes it easier. Other thing we're doing is we've started a logo program. All of our designs are open source. We make sure that you can go get those parts from the DigiKeys, Mousers, and Element 14s rather than AliExpress and kind of hoping that you get them. We make sure that people actually can replicate the things that we're doing. Of course, we have a fantastic partnership with Seed Studio guys. They're here. They've created the BeagleBone Green and actually helped lower the price for getting BeagleBones. We work with the local manufacturing in Michigan. We work with the large guys, Element 14, and a number of other people adding value. And we're really open to bringing on more people that want to logo certify their boards. So that they are supporting the BeagleBoard community. But of course, if you want to take the design and make your own boards and do other things without us, there's nothing stopping you from doing that. But we do appreciate people that join the community. That's my 1-minute wrap-up sign, so I'm just going to go back over my key points. Kind of a simple talk today, but I do hope that some of you walk away from here thinking about doing things in these large collaborative projects, and how you go and advance the tools that we're working with for board design today to make sure that they can be collaborative. So we can use tools like Git and manage history, work in a textual way, work in an open email type of environment. And of course, if you have any interest to work with BeagleBoard, please feel free to contact me. I really appreciate you guys' time, and it feels like family when I'm here and speaking with the folks at the Open Hardware Summit. So thank you very much for your time.